Good morning. So we are now on quarter 3, week 6 of our MELC, or the most essential learning competencies. And for our discussion, we are going to discuss about the area of a composite figures. So for our learning objectives, we are going to first find the area of composite figures formed by any two or more of the following. So we have the triangle, the square, the rectangle, circle, and a semicircle. And also solve routine and non-routine problems involving area of composite figures formed by any two or more of the following. So we have the triangle, square, rectangle, circle, and semicircle. So let's define first what is an area. So when we say area, it is a number of square units that covers a surface. It is measured by square units. So I have here some examples. For the first rectangle, we have 8 square units. And also for this one, we have also 8 square units. Okay, so now let's define what is a composite figure. When we say composite figure, it is made up of several simple geometric figures such as triangles, rectangles, squares, circles, and a semicircle. To find the area of a composite figure, separate the figure into simpler shapes whose area can be found. And then we are going to add the areas together. Be sure that none of the simpler figures have overlapping areas. So here is an example of a composite figure. Let's start with finding the area of the square, which is the simplest form of geometric figures. Why? Because all of the sides of a square are the same. So for the formula in getting the area of that, we have area is equivalent to side times side. We are going to substitute the values. So what are the sides? We have 5 centimeters and another 5 centimeters on this side. Now, we're just going to multiply. We have 5 centimeters times 5 centimeters. Then we will get an area of 25 centimeters squared. So that's how you're going to get the area of a square. Next, how about for a rectangle? For a rectangle, we have two units of measure, which are the length and the width. So for the formula, we have area of a length times width. So we have here, for the length, we have 25 decimeter times 12 decimeter. We're just going to multiply the length times the width. So we have 25 times 12. It will give us 300 decimeter square, or 300 square decimeter. So let's proceed for the other examples of geometric figures. So let's have a parallelogram. A parallelogram has, or this parallelogram has a measurement of 4 centimeters and 10 centimeters. So given the formula of a parallelogram, we have area is equivalent to base times height. So we are going to substitute the values, which are, for the base, we have 10 centimeters. And then for the height, we have 4 centimeters. So we're just going to simply multiply this. You have 10 centimeters times 4 centimeters. We have an area of 4 centimeters square. Next, we also have this simple figures. So we have a triangle. For a triangle, We have here 4 centimeters as its height. So this is the height of a triangle. And the base, which is 6 centimeters. So in getting the formula, or in getting the area of a triangle, we have 1/2 times base times height. So again, we have 1/2 times base times height. We are going to substitute the values. 1/2 times, what is the base? So it is 6. And then for the height, we have 4. So we have here 4 centimeters. Now we're just going to multiply. So 1/2 times 6 centimeters times 4 centimeters. 6 times 4 centimeters will give us 24 centimeters. Now, multiplying it in half, what is the half of 24 centimeters? So we will get 12 centimeter square. So that will be the area of this triangle. Let's have some more geometric figures, and let's have a trapezoid. For the trapezoid, we have a formula in getting the area. So we have 1/2 times B1 plus B2 times your height. What is this B1 and B2? If you're going to look at the trapezoid, you will notice that it has a different bases. So this base is different from this base. So in this trapezoid, we have the B1, or the base number 1 is your 8 centimeters. And then for your B2, or your base 2, it is 12 centimeters. Then multiply it by the height, which is 4 centimeters. So this is your height. Now we're just going to multiply 8 centimeters, 1/2 times 8 centimeters plus 12 centimeters times 4. So we're going to solve first these two. So 12 centimeters plus 8 centimeters, we have 20. So 20 centimeters times 4, we were going to have 80 centimeters. So 80 centimeters times 1/2, so what would be the half of 80? We will have area of 40 centimeter square. So that will be the area of this trapezoid. Next, let's proceed with the circle. For the circle, we have a formula of area is equivalent to pi r squared. This is read as pi. This one is read as pi. And pi has a constant value of 3.14. So when we say constant, it doesn't change. It is fixed. It's its value. So 3.14. Next, for r, this is what we call the radius. In this circle, our radius is this one. Our radius is this. So our radius is equivalent to 2 centimeters. So substitute the values. We have 3.14 times 2 squared. 2 squared is equivalent to 4. So 3.14 times 4, we have an area of 12.56 centimeter squared. So this will be the area of this circle. Okay, so those are the different formulas in getting the area of a specific figure. Now, let's proceed with a composite figure. So, as we all know, a composite figures is made up of two geometric figures, two or more. So, for our first example, I have here a square, and inside a square, we have a circle. And we have a shaded areas uh, for the squares. So, we have here this one, and this one. These are the shaded areas of a square. So for us to solve a composite figure, we're going to solve it first. We're going to separate it And we are going to solve for that. So, given the side or the value of side, we have S is equivalent to 10. Since this is a square, all of its sides are the same, right? So, to get the area of the shaded region, we are going to get the area of a square minus the area of the circle. Okay. Now, let's write down the formula. So, we have S squared for the square, and then pi r squared for the area of our circle. Substitute the values. So we have 10 squared times 3.14. Mom, where did you get the 5? Following here, if we have side here of 10, eventually this one is 10. But since we need to get the half of it or the radius for that, the half of 10 is 5. So that's why I have 5 here. Okay? Next, we are going to solve. 10 squared will give us 100. Copy 3.14. So here's a 3.14. And then 25 times 5 or 5 raised to 2 will give us 25. Next, we multiply first these two. So we have copy 100 minus 3.14 times 25 will give us 78.5. Then we can now subtract. 100 minus 78.5, we have a value of 21.5 centimeters square. Therefore, the area of those shaded regions are 21.5 centimeter squared. Now, let's proceed for example number 2. For this one, it has a two-way to answer this. So for example number 2, I have here a rectangle and there's a triangle on its side. So on both sides, it has a triangle. And we have a measurement of 8 units and 3 units for the triangles. So we are going to get the area of a shaded region. So we are going to get the area of a rectangle minus the area of a two triangles. Because if you're going to notice, we have here the first triangle and here is the second triangle. So going back, in getting the area of your rectangle, we have a formula of length times width. And then formula in getting the area of a triangles, we have 1/2 times base times height. And mom, what is the 2 here? Since we have two triangles, so we have 1 and 2, we are going to multiply 2 to represent the number of triangles. So substitute the values. For the area of rectangle, we have the length is your 8 units, sorry. And then for the width, we have the 3 units. So this is the width for the rectangle. So we have 3 units. Next, minus 2 times 1/2 for the formula of triangle. 1/2, 3 times 3. Because one triangle has a height of 3 units and a base of 3 units also. So we're going to substitute 3 times 3 here. Next, so 3 times 8 or 8 times 3, we have 24 minus 2 times 1/2 times 9. Because 3 times 3, we have 9. Next, so we can get the half of 9 since it's not an even number. We are going to solve first this one. So we have 2 times 1/2. So if we're going to give this a value or a ghost denominator of 1, we will going to have 1 times 1/2. And if we multiply it, we can cross multiply or we can cancel. This will become 1 and this will become 1 also. So therefore, we have 1 times 9. It will become 9. Bring down the 24. So we have 24 minus 9. We have 15 units or 15 square units as the final answer. So in this problem, we use the area of a rectangle and the area of the square. triangle, sorry. For the other solution of that composite figure, here I'm going to use, or I'm going to get the area of a trapezoid. So how are we going to do that? First, we are going to get the length. So we have 8. Then I'm going to subtract the units that we have. So I have 3 units and another 3 units for this base. So 8 minus 3 will give me 2 units. Therefore, this base has a 2 unit measure. 2 units measure. Okay? So using the formula of a trapezoid, we have area of a trapezoid is equivalent to 1/2 times B1 or the first base plus the second base times H or the height. So we're going to substitute the values. 1/2 times 2. Ito po yung nakuha nating unit kanina here. So we have 2 plus 8 times 3 because our height here is 3. Still our height is 3. So 1/2, 10 times 3. So we have 30, and then 1/2 of 30, we have 15 square units. So this one is much easier than the first one. But I still show it to you so that you can use any other or other solutions. Okay, so let's have example number 3. For example number 3, I have here this composite figure. So what do you think are the shapes or the geometric figures that we have here? So I think you already know. So we have 2 rectangles. So for the formula, in getting the area of a rectangle, we're just going to multiply the length and the width. So we're going to get the area of a first rectangle added or plus the area of the second rectangle. So given the values, for the first rectangle, we have the length as the 10 meters, and for the width, we have 8 meters. So we have 10 times 8 here. And then for the second rectangle, we have your length as 12 meter here, and then the width is 4 meter here. So we have 12 times 4 is 48, and 10 times 80 is 10 times 8 is 80, sorry. And if we're going to get the sum of 80 plus 48, we will get 128 meter square. For the last example, example number 4, I have here this composite figures, and these are the units or the measurement. So for this one, we can say that we have 1 rectangle and 2 squares. So we are going to get the area of a rectangle plus the area of 2 squares. So writing down the formula in getting your rectangle or the area, we have length times width. And getting the form or the area of squares, we have s squared or s raised to 2. And then we have 2 here, which represents the number of squares we have. Substitute the values. We have 5 for the length and 15 for the width. And then plus 2 times 5 squared, because the side of each of the square is 5. So we have 5 here and another 5 here. Next, we have 5 times 15 is 75 plus 2 times 25. Since 5 squared is equivalent to 25, we have 2 times 25, we have 50. Then bring down 75. 75 plus 50, it will give us 125 square decimeter. I think it's your time to shine. So what I wanted to do is to answer this activity. What's more, find the area of the following figures. So we have the first one here, the second, and the third one. What you need to do is first identify what are the different geometric figures that are given, and then you're going to use the formulas. So what I wanted to remember is that in finding the formula of the area of a plane figures for the square, we have A is equivalent to S squared. For rectangle, we have A is equivalent to L, W, or length times width. For parallelogram, we have A is equivalent to BH, or base times height. For triangle, we have A is equivalent to 1/2 of BH, or 1/2 times base and times height. And then for the trapezoid, we have A is equivalent to 1/2 times B1 plus B2 times H, or 1/2 times the base 1 plus the base 2, or the first base plus the second base times H. And for the circle, we have A is equivalent to pi r squared, wherein your pi has a constant value of 3.14. Thank you so much for listening. I hope you learned something today. Thank you and God bless you all.